Okay, we're live now. Hi everyone, this is Hossein from EJ Academy. This is another tutorial on limit in calculus, and my guest today is Amir.
Hello, my name is Amir. Nice to be with you here.
Okay, Amir, I have another limit problem for you today, and this is a continuity problem. So what you see on the screen is a piecewise function f of x at for x less than 5, the value of f of x is defined as the absolute value of x minus 5 divided by x minus 5. And at x equal 5, the function is a times x divided by 5 minus b. And at x values greater than 5, the function is defined as a plus 10b divided by x. And in this problem, you're going to find a and b. These are two unknowns. You're going to find these values such a way that the function is continuous at x equal 5. So the floor is yours.
Yes, yeah, that's interesting problem. Okay, we have to find a and b such that the function is continuous at 5.
Mm-hmm.
Correct? Okay, to have a continuous function, we need to, at a point, which is 5 here, we need to have the limit of that function at that point, the left and right to be equal. In other words, the limit should exist at that point, and also the value of that function at that point should be defined.
Okay.
So let's start with the limit.
Can you write that down,
Yeah,
the theorem or the law that you're going to use for this
sure, yeah,
problem?
absolutely. We have the theorem that limit of f(x) when x approaches to 5 from left side should be equal to limit of f of x when x approaches to 5 from right side.
Right.
Okay, and this is the limit condition, and
And
the
for the
other condition,
continuity,
yeah, and then the other condition for continuity is that f of x at 5 exists. Correct?
right. And it has to be equal to the value of the limit.
That's right. If it's like, let's call it C, then this should be C. Correct?
Right.
Okay. So let's start with the first condition, the theorem of for the limit. Limit of f of x when x approaches to 5 from the left side. Okay, since it is approaching from the left side and this is a piecewise function, we consider this one.
Right, the first statement.
Yeah. So, oops, let me change the pen. Okay, to the pen. And it's going to be a limit of absolute of x minus 5 divided by x minus 5 when x approaches from the left side. Okay, we have absolute function on the numerator of this fraction. Since x approaches from the left side, the numerator is going to be negative of x minus 5.
Okay.
So we can get rid of the absolute sign. because with the absolute sign, we cannot do anything.
Right.
So it's going to be, as I said, since it is from the left side, we have negative value here. It's going to be x minus 5. So instead of the absolute sign, we have the bracket, the parentheses, divided by x minus 5.
I think it's going to be helpful for the viewer to to visualize easier if you can draw the function of absolute of x minus 5 maybe on the side. Yeah, can you draw a quick sketch showing how
Sure.
the function look like?
Yeah, please help me on that.
Yeah.
So let me change the color to, let me see, like green. If this is x-axis, this is y-axis.
Right.
And say it is, this point is x equals 5.
Right. So
So
I usually use a technique for like this kind of functions. So I start from y equal x, which is a line going from the origin, passing from the origin in 45-degree angle. So maybe draw that line with like a dash line.
Yeah, sure.
First, right. And on the negative side. Okay, that's good. So this is y equal x. And then when you have y equal x minus 5, you shift it to the right.
Correct.
5 units, right? So maybe draw another dash line, shift it to the right.
X minus 5, and we say, okay, at what value y is equal to 0? So it's going to be at x equals 5. So because of that, we have x equals 5 here.
Right.
And the curve, not the curve, the line should shift to the right.
Right.
So that's why.
So you want to draw another dash line.
Yeah. Let me change the color here to like orange. I try to keep the slope, the same because, oops.
Right.
Something
so
like
this is y equal x minus 5.
Correct.
And then what the absolute sign does to the function, it just make all the negative values positive. So what you're gonna do here, right? Go ahead. Sorry.
Thank you. So it's going to be like that. Am I right?
Right.
Instead of the this part, below the x-axis, everything absolute value does to the function is that it shifts everything to the top of upper portion of the x-axis.
Right. It's like you are making a mirror of that function.
Correct.
Whatever you have below the x-axis, you draw the mirror of that.
That's
above
correct.
the x-axis. Okay.
Yeah.
Okay. So this is how absolute of x minus 5 look like. And then as we see here, for the values less than x equal 5, so we just need to multiply a negative sign to the x minus 5, and then we can remove the absolute sign.
That's correct, because this portion is also x minus 5, but with the negative value. So to shift it to the top side, of the x-axis, we need a minus sign here. That's why we actually multiplied here the negative sign.
That's correct. Okay. Yeah.
So yeah, thanks. Let's see.
So let's go back to the limit problem.
So then, yeah, we have here, let me change this to this color. Here you see we have this fraction, x minus 5 divided by x minus 5. Since that's a limit problem, we can divide, numerator by the denominator, because we are sure that the x value is not going to be exactly 5. Because if it's exactly 5, it's going to be, sorry, I have to change the pen. It's going to be 5 minus 5 divided by 5 minus 5. So 0 divided by 0, it's undefined. We cannot do that. But since this is a limit problem, and we know that the x value is actually everything other than, the exact value of 5, then we can divide these two numerators and denominators. So it's going to be, they can be canceled. And what we have left is just -1.
Right. Okay.
So,
yeah, this is because a limit problem, you can cancel that out, whatever you have in the numerator and
because we
denominator.
know that x is not 5.
Right.
X
It's approaching
approaches to 5. It's like 4.9999 whatever. Or
right.
if it's
It's
from
not
the
gonna
right
make it
side,
0.
yeah, that's correct.
Okay. Okay, fair
So,
enough.
okay, that's one condition here. We just looked at this condition.
Right.
So we now look at this condition. So let me just call this one number 1 here. So the other condition, limit of f of x, x approaches to 5 from the right side. Since it's from the right side, and when since we have the piecewise function here, that is going to be this one.
Right.
So it's going to be a, limit of a plus 10 b over x. X approaches to 5 from the right side. It's a simple function. We just replace x with the approaching value.
Right.
Here's 5 here.
Right.
So it's going to be a plus 10b divided by 5.
Right.
So it's going to be a plus 2b.
Correct.
I call it number 2 here.
The
result number 2.
That's correct.
And that's, we know so far we covered this condition. Now we look at the actually continuity condition.
The value of the function.
Value of f of x exactly at the same value of 5. So f of, let me just write like this. F of x at 5 is equal to this one.
Right. The second statement.
Yeah. I replace x with 5 times 5 divided by 5 minus b. So it's going to be a minus b.
Right.
So yeah, easy peasy. That's the result number 3. And we now look at condition number 1 again here. this guy,
Mm-hmm.
for the limit to exist, we have to have result number 1 to be equal to result number 2,
Mm-hmm.
correct?
Right.
So then we can have the limit. So I use that condition here. And let me just use this color. 1 equals 2. Result number 1 equals result number 2, which is actually minus 1 equals A plus 2B.
Right.
Or in other form, A plus 2B equals minus 1.
Right.
So that is one equation that we need to solve,
Right.
to
As
obtain those
two
two
unknowns, so we
unknowns.
need
Yeah,
another equation.
that's correct. So let me just, this one equation. The other one is that the value of the function should be equal to the limit value of that
Right.
function.
Mm-hmm.
So
The
using
value
that,
is the one that you got in number 3,
yes.
A
So
minus B.
correct. Let me see. I call it number 4. So number 3 should be equal to number 4.
Mm-hmm.
Therefore,
Actually, I think number 3 should be equal to number 1.
um,
The value should be equal to, because you only have one of the limits, you
yeah, we
actually
know
have a
that's
value
correct,
for it.
because this one again gives us, another equation with unknown.
Right.
So,
Okay.
okay,
I think what you wrote is correct, but I think it's easier to
just
assume that
consider,
3 is
yeah,
equal to 1.
yeah, sure. 3 is equal to 1.
Mm-hmm.
So, A minus B is equal to -1.
Okay.
So this is result number 5.
Right.
And then, okay, it seems that I'm at the end of the page.
Okay. So you have right now, so far you got 2 equation, number 4 and number 5 with 2 unknowns, A and B.
Correct.
Okay. And then what are you gonna do from here?
I consider both of them
Mm-hmm.
here, and then this guy
Mm-hmm.
here.
Right.
Just need to solve this equation. What
Okay.
I can do
So you got
is
a
that,
system of equation.
yeah, system of 2 linear equations. So I just multiply the second equation by 2.
Mm-hmm.
So what I get is that A plus 2B is equal to -1.
If the viewers curious how to solve it, why we multiply by 2, you need to go back to algebra and look at the techniques to solve system of equation over there.
That's correct. And then I multiply by 2 because I'm just going to get rid of one of them.
Right.
I just chose B. I could
Right.
have chosen, A instead.
Mm-hmm.
So right now I can add 2 equations on left side and right side.
Mm-hmm.
And when I add, what I get is 3A is equal to -3.
Right.
So that easily gives me a is equal to -1.
Right.
So that's one answer. And another answer, again, I can again use result number 5, for example, or which is this equation. I use
Right.
this equation to obtain b. So
So just plug in the value of A and then you get the value of B.
correct. And let me just change the color to like this one. And from that, I plug it just here. Minus b equals to -1. So I move b to the right side. So b is equal to 0.
Right.
Am I right?
Right. Yeah. Yeah. B has to be 0 to, that equation to work.
Yeah.
Okay.
So
so those are the values of A and B to have that function be continuous at x equal 5.
That's correct. So b should be 0 and a should be -1.
Right.
For this function to be continuous. Yeah.
Okay. Yeah, thank you, Amir. We're running out of time. I just wanted to wrap up what Amir did here and just quickly explain. So we had, for the continuity, we had two conditions that Amir wrote at the top of the page, condition number 1 and 2, basically saying that the limit of the function from the left and from the right, they have to be equal to the value of the function at that point. And we got 3 equations, 1, 2, and 3. And what Amir did here, he put all these 3 equations equal to each other, and we had 2 unknowns, A and B, and at the end, he got 2 equations with A and B, and basically he got a system of equation with A and B as unknowns, and he solved that system of equation and found the value of A and B to be equal to A equal -1 and B equals 0. And with those values, if you put that back into the function, that function would be continuous at x equal 5. Thank you, Amir. Thanks for helping to solve this problem. And for the viewers, that's all for today. And thanks for watching.
Thank you.
Bye.
Bye.